Hi class, it's Mr. Schraub. For tonight I wanted to make you guys a little video to help you make sure that you could get through on the homework. In class we were talking about how to make graphs and how to, in particular, make line graphs today. One of the important things that we were talking about is this idea of dry mix, is what we refer to in class. And that is one of those aids to help us remember where things are on data tables and then where we're going to put them on a graph. In math class, you guys have been working to identify for years now your x and your y coordinates. It's going to work the same way in science class, where this first column that I've highlighted is going to be your x, and then the second column is going to be your y. In science, we're going to also have some other information in there that we're going to need to keep track of. Since this is your x, that's going to help you remember. We're going to call this one our mix column, and that mix stands for manipulated independent variable, and it goes on the x-axis. The second column, we're going to call that our dry column, and that dry stands for dependent, the result of our experiment, and it's going to go on the y-axis. And we've looked at a graph over here that uses that same information. Our mix is going to be down here on our x-axis, so we're going to use the title from that column to be located here on the x-axis, our independent variable. And we're going to use the dry to help us make this axis over here our y. And so we'll know that the title of our y column is going to go onto the title or the axis over here. One of the first exercises we worked on in class was making sure that we could build graphs. And I came up with these 7 steps that you guys should follow to make a good graph. And so first thing we need to do is make sure that we can identify variables. And that's going to go back to our dry mix, remembering that the left column of the data table is going to be your x-axis. The right column or columns will be your y. Once you've identified those independent variables, it's generally a good idea to find the range of your data. And remember, to find the range, you're going to take your highest data point and subtract your lowest point from that. So it's going to take your high data point, subtract it from your lowest data point, and that'll give you the range. You're going to do that for your x and your y. What that's going to do is help you determine the scale for your graph. Tonight's homework, if you don't look at that, those ranges and your graph, you're going to end up with a tiny little graph down in the corner, and we don't want to do that. Once you've determined a good scale and it's going to take up most of your graph paper, then you're going to put your numbers in and label your axes. So make sure that you're going to label that the x-axis with your independent variable. You're going to label your y-axis with your dependent variable. Once you've done that, you're going to go in and use your xy data to make your data points. Once you've put your points in there, you'll draw a line, not necessarily connecting the dots. We're going to try and either have a smooth line or a straight line in our graphs. And the final step for making our graph is we're going to title our graph. And the easiest way to do it is to simply title it x versus y, where y versus x, where the y is the dependent variable and your x is your independent variable. So your title for the helicopter lab, in particular, the one that you need to title today, should be something like time versus what it was that you manipulated or changed in the experiment. Many people changed the number of paper clips or the mass or the length of the wing. So your title should be time versus length of wing, or time versus number of paper clips added. As for what we did in class, most people did pretty well on this first page. Which point is at 0, 6. Remember, the point going across for 0 is kind of that chest pump. That's the x-axis. And so since this is 0 for the x, we're not going to go anywhere on the x-axis, and we're going to go up. Point up for the second one. That's going to be 6 for this case. So the point that is at 0, 6 is R. We're going to skip down. Most of us did pretty well and confident on these ones. I'm going to jump to this next page for the homework where you guys were working on it. For the independent variable for your homework, all you had to do was write down the title for the first column there. And so the independent variable in this one would just be the pH of water. So that is the first column. Remember that first column is the mix column because it's the X one, and that's also going to tell us it's the independent variable. Oh, we could also answer 3 at the same time. That's also going to be pH of water. Yay. As far as the dependent variable, that's just the title of the other one. So that's going to be just the number of tadpoles. And again, same thing holds true for down here for the y-axis. It's going to be number of tadpoles as well. Like we were saying earlier, to title this graph, it's going to be your y versus your x. So it would be, in this case, number of tadpoles verse, and then your x, which was, in this case, pH of water. This graph was a little bit trickier and intended to be so. So on this data column, the independent variable is just like before. We're going to be looking at that first column to find our independent variable right here. Once you've found the independent variable, the dependent variable becomes a little bit questioned because we haven't seen 3 columns before. It turns out these are both going to be our independent variable. These are both the results. This is the result from forest A, and this is the result from forest B. We had 2 results because we were at different places. And so we're going to graph both of those, and this is the scenario where you would have 2 lines on your graph because you had 2 different sets of results. And so our dependent variable in this experiment would be the average thickness of the annual rings. And if you want, you can include the in centimeters. You don't have to include forest A and B. So the title of the y-axis down here, again, would be the average thickness of the annual rings measured in centimeters. For your data range, remember, it's going to take your maximum number in your X set and then subtract from that your lowest number. So right here, 10. So it's 60 minus 10, and you guys can find the range there. Again, for the Y, it's a little bit trickier because you have 2 different data sets. We are going to try and put these on the same graph. And so we're going to have to make sure that we have the full range there. So you're going to take the largest number, which is here, 4.5. And the smallest number in the total data set, which is 2. And so you're going to find your range using those 2 numbers. Again, for the title of this graph, it would be your Y versus your X. So something along the lines of average thickness of annual rings versus age of tree in years. Going on to the part that you guys, for the most part, had to do for homework, I just gave you a data table here, and you guys had to make a graph of this. And so based on what we talked about earlier, the first thing we need to do is identify our variables. And so this, in our first column, our X, is going to be our mix column. So this is going to be on the X-axis. This is our independent variable, and that's what got manipulated or changed in the experiment. And so that's the set we would deal with first. And this is going to be our y-axis because this is in the dry column. This is going to be our dependent variable or the result of the experiment. When you look at your data table and then look at your graph, we're going to have to figure out how we're going to fit this along our graph. We did decide that down here we need to put a title. And so our label our axis down here. So the label for our x-axis in this experiment would be depth in meters along the x. So down here along the bottom of your graph, I can't type it in, there's no room, sorry, is going to be your depth in meters, and you're going to label your y-axis the number of bubbles per minute over on your y-axis. So you're going to write that over to the side over here. Once you've done that, then you're going to need to find a scale. If you counted across the bottom here, you should see that you had a little over 30 lines to use for this graph, which is enough to fit just with 1 line per number. You can make a nice graph going across your X here. Your Y, however, did not have enough lines, and so you probably needed to make each line worth 2 to make your graph fit in there. Once you've done that, you're going to find your data points up here. Your first data point would be 229. And so for this graph here that we were working with, you would come over 2, and you were going to go up to the 29. And for most of you guys, the lines are going to be worth 2 each. So I'm going to count up the number of lines I need to get there. So I need to get to 30, and then I'm going to count back 1. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That would get me to the 30 spot if each line was worth 2, and then I'm going to go back half a spot. So your first data point should be just about here on your graph at 229. And so make sure that you're following that. You guys can graph out the rest of the data there. As far as the follow-up questions down here, again, what's the independent variable? You should remember that. That's going to be what is on the x-axis. Why is it the independent? Well, think about what the independent is and describe what an independent variable is for me there. Your dependent variable, again, that's going to be your y. And tell me what was in your y column there, what you put in your y-axis, and describe to me why that's the dependent variable. And then here for number 5, just please explain to me what you notice in the graph after you've graphed it out. Is there a peak amount of bubbles that you get, and when does that occur? So what do you notice about the graph? As for the assignment for helicopters, let's take a quick look at that graph. For completing the graph for your helicopter lab, again, it's similar to the other ones. The data table for the helicopter is going to have 5 columns. You don't want to graph the trials. That's just too much data to put onto a graph. And so rather than graph all of that information, what you're going to do is just graph that last column, the averages that you guys calculated, and it's going to make your graph look a lot cleaner. And so just like the other examples that we were working on, what you're going to do is along your x-axis down here, you guys are going to put your independent variable, the thing that you guys changed. For the most part, it's going to be the number of paper clips. Along your y, it's going to be the result of the experiment, which was going to be time for most of us. And for your graph title, it's for the most part going to be time versus the number of paper clips added. Again, you're just going to try and find appropriate scale, especially for this paperclip lab. You don't want it just sitting down in this tiny corner down there, which it might be if you added 4 paper clips and it only lasted 2 seconds. So make sure that you stretch that graph out and get those points onto a nice looking graph. Hope that helps, guys, and look forward to see you guys tomorrow. Take care.